Hi, Chris Kuzma here, and we continue with our discussion of truth assignments and evaluation for relational logics. So actually, let's go back. A reminder that a truth assignment, every truth assignment can be associated with a number, if you will, and we can name that number I. And so truth assignment number I for an Erbron base, which has relations P and Q, objects A and B, and an arity of 1 and 2, is going to be that ith truth assignment could be, for example, P of A is 1, P of B is 0, Q of AA is 1, Q of AB is 0, Q of BA is 1, Q of BB is 0. And I should have been saying true for 1 and false for 0 here, but hopefully you catch my meaning, that we've given a particular set of truth values to each individual element of the Erbron base, and that particular assignment is given the name I. So I applies across all of these. In fact, some people would create a binary number, the number 101010, and make that binary number be the name of the truth assignment. Okay. And that's still a little abstract, a little formal. Let's go do a little bit more formality, and then we'll give some more concrete examples. So how many truth assignments are there for a given Erbron base? The answer is it's 2 to the power of the number of sentences. And so here we have 1, 2, 3, 4, 5, 6 sentences. So it's going to be 2 to the 6th in our example. And that's the number of truth assignments for a given Erbron base. So once we have a truth assignment, we can evaluate a logical sentence based on that truth assignment. And the way we do that is really the same as we do with propositional logic. But we're going to look at 6 different examples. One example, we say for all x, blue of x implies Dash is cute. Another sentence is going to look almost identically the same, but the scope of the for all, scope of the quantifier extends because of this parentheses to include the right-hand side of the implication operator. Another case where we use a binary relation on the right-hand side of the implication operator. And then 3 other examples using the existential operator. The first 2 examples, 4 and 5, are identical to examples 1 and 2, but we replaced the existential operator, we replaced the universal quantifier with the existential quantifier. And then in example 6, we go super crazy, and we do a for all x and a there exists y, which is sort of a doubling down on the amount, actually squaring up, if you will, on the number of different sentences or sub-sentences or clauses, whatever you want to call it. In other words, the ground form of example 6 is going to be huge. Okay, so overall, to evaluate any of these examples, we need to have a truth assignment for each relational sentence. That requires us to note the vocabulary for the relational world we're using. And our example that we're going to use now is different from the examples you've seen before. So, because I had to try and choose the right size, it's going to be 4 object constants: Dasha, leopard, ball 1, and ball. Oh dear, misspelled. That should be ball 2 here, not ball 1. Okay. And we also have a period here where there should be a comma. We have our set of relations, blue, cute, and kicks, and then the arity of those relations is 1, 1, and 2, respectively. In other words, a thing is blue, a thing is cute, and then one thing kicks another. And so the Erbron base has 4 members as a result of the unary relation blue for each of the 4 object constants, 4 additional elements for each of the unary relations involving cute and the 4 objects, and 16 additional members for every pair of object constants that could be having one kick another. Note that this includes an object kicking itself. And on the next slide, we list all of these, all 20 of these, and you can enjoy yourself, maybe freeze the video or something to read them. I'm not going to read all of these to you. But each of these 20 in theory, in principle, must be assigned to true or false in order to have a truth assignment in this particular relational logic.